老师用这个吗？好。
So today we will address homework 2, and copy homework is strictly prohibited. Homework 2 due date is 9 o'clock December 1st.
老师2个礼拜后可以吗 ？OK。
And no delay up to 7 days late. Those
3个礼拜吗？好，那就改12月8号。
So you have the 3 works to do the homework 2, and no delay up to 7 days late. Those are 50% of the score awarded. After 7 days, the score will be marked as 0. And you must attend the demonstration or your score will be 0. And you must make a GUI and follow the format or you will do some penalties. Please upload your homework 2 to FTP. And from question 1 to 4 are compressed to a folder and upload to the folder named homework 2. Question 5 needs to upload separately. And you need to upload the project folder, excluding the data we provided, only the source code and model. And we recommend you use the Python to do homework 2. And homework 2 have 5 questions. Each question has 20 scores. And this is the GUI example. Don't fix your data path. There is another data set for demonstration. And question 5 needs to upload separately. Question 5 GUI sample will show you later. The question 1 is about the background subtractor. I will give you a video named traffic, and you required to do is the click button and show 3 windows. First one is origin video, and second one is max video, set background to black and foreground to white. Third one is foreground video. 2, use first 25 frames to build the background model. 3, do not use any OpenCV function like CV to create background subtractor. And this is the demo video. So the left one is the origin video, and middle one is max video. Right one is the foreground video. So you need to choose the video and click the button to show the 3 windows. And you need to do is build the Gaussian model for background. So first one, you need to use the first 25 frames. And each pixel has 25 frames. So use the 25 frames to build a Gaussian model at every pixel position. So each pixel will have a mean and a standard deviation. So you will get a total of width by height Gaussian models. Second one, you need to remove the background. So if the differences between the pixel and Gaussian mean is larger than 5 times standard deviation, so set the max to 255, otherwise set to 0. So this is the example. If the mean is 25 and standard deviation is 3, so if the pixel is 28, the differences between mean is 3, so it's less than the 15. So this pixel is belong to background, so set the max to 0. And the other one, if the pixel is 16, and the differences between the mean is 35, so it's larger than the 15. So this pixel belongs to foreground, so set the pixel to 255. So after this, you will get the max video, and you use the big width and combine the origin video and max video, you will get a foreground video. So there are some hints. You can follow the hint to do the question 1.
那个 hint 就是刚刚讲过的，把它列出来。
For the second question, you need to implement optical flow. And this question is specified by 2 parts. First part is pre-processing, and second part is video tracking. And for the pre-processing, you are given a video called optical flow.mp4, and you can the video is about you can see the left photo and it's about leg and on the leg there's several blue points, and this question you need to detect the 7 blue circle and display first image, the first frame only, and you need to detect and draw a mark on the blue circle by the right image. As a result, you need to draw a mark on it and a reticle around it. You can draw it by the OpenCV function, CV.reticle and CV light. And you can detect the blue circle by using the CV2 simple block detector created to detect the block. And this function has several parameters. And for you can change there's some sample here, and you can change it until you detect the blue circle as the result in here, the 7 blue circle. And there's some parameter like area is how big your block is, and color and circularity, interior and convexity. And you can I can explain it to you. The area is how big your block is, and the color, but this about the grayscale. So and this circularity, and is for 0 to 1. To 1 is a perfect circle and 0 is a triangle. Interior is about how the circle is the big, the large axis and the linear axis. So for 0 is like that, and for 1 is like that. And okay. So you can change it until you get the correct result. And after you detect the 7 circle, you can do the video checking. This is the sample demo video. So after you detect the 7 blue circle point, you can use this as a good feature point and feed it to the CV2 kind of optical flow and check this 7 points and show this result. And the tracking process may have some errors, so at least 4 to 5 points is okay. There's some tips you can check, some about low video, circle detect, optical flow, and tutorial.
Six points, but if they can check successfully the 4 or 5 points, that's fine.
You can in the first process you need to detect 7 points, but for the second question, 4 to 5 is okay. For the point detect, you can use the single block detector. Okay. Any question? No. Okay. It's good.
Problem 3 is about a perspective transform, and you need to do the following step. First, read the test video and the process frame by frame. And the second, detect the ARU call. Mark inside the frames. And the third, get the pixel position of the 4 marker in the frame, this 4. And do the perspective transform and show the results video. And your user interface will like this. You need to click the button to load the video and load the image. And click another button to show the results video second. And your results will like this video. And there are more detailed hints about this problem. You will use the OpenCV function to detect the the 4 ARU core position about the ID1, ID2, ID3, and ID4. And project the image corner on the ID1, ID2, ID3, and ID4. And you can also use the hint, the five OpenCV functions to do the list process, and you will get the results like this. And does anyone have any problem? Oh, okay. Next.
Not clear. So after they find the ARU code, right?
And you use the find homography, this OpenCV function, to find the matrix, and use the warp to project this image on this plane to get the results.
Clear about this. So first of all, you should detect the ARU code. Right? This one.
Yes. Detect the ARU code.
To detect the ARU code, right?
Will get the.
But because suppose you have 50 frames, right? Video have 50 frames.
Yes.
So for each frame, you should detect the ARU code. Right?
Yes.
Yeah, you didn't say that. So
Yeah.
for each frame,
Inside the frame.
for each frame, you should detect the ARU code. It just said detect, but for each frame, you detect the ARU code. And for each frame, after you detect the ARU code, what's the homography?
This one just detects the position of the ARU code, and will use this position to get the homographic matrix.
So you have detected 4 ARU. Detect 4 ARU code markers. Another 4 ARU code markers. Detect 4. Another 4. Detect 4. Second one. Detect 4. Another 4 ARU code markers. Because they don't understand what's the frame. So the image also called frame. So your definition is, what's the definition for your frame? That one?
Yes, it's the video of the.
Because the video also called frame.
Mm.
Test the video and the process frame by frame. What do you mean inside the frame?
Or maybe this one is inside the videos. Inside the
It's fine,
One-
frame.
one
Because
frame.
I suppose that one is also frame. The marker, that one is also frame, so that's not frame. That's that. So inside, now for each dictate for ARU cost for each frame. For each frame. So after dictated ARU call it for each frame. And then what's the next one?
and will get the position of the ARU core in the one in for each frame.
So get position for each marker. ARU call marker. Get position. Get position X, Y for each ARU call marker. Right. So it's so position. So that one you call which function?
Will call the these three OpenCV function. Call this OpenCV function to detect the marker position.
11. Get the position of each marker. Of each marker. That's right. That's right. Get position X, Y for each marker. Right, of each marker and for each marker. Sorry, get the position of each marker for each frame. Each marker for each frame. That's right. Each marker, not S. So you have 4 markers, right? And 4
Yeah.
position, right? And 4 perspective transform. You want to transform to where? From where to where?
From the image corner to the
So where
this
is it?
position.
So logo, right? So you give student the logo, right?
Yeah, the image.
That's clear. Click the button to load the video and the logo. So you transform is from where to where. So you make or transform the logo, mapping the logo image to make the logo image to. This is based, I think, based on the position, based on 4 positions. Here, by using perspective transform, something by using perspective transform. Based BASD, based on 4 marker position. Is a transform the logo 4 corners. Mapping 4 make a 4 make the logo to based on 4 corresponding marker corresponding corner position. Which is anyway, the purpose you want to transform map from the logo to the ARU code, right?
Yeah.
Insurance something like that. Otherwise, people don't understand. Using perspective transform. Four corner mapping to the other four corner. For each frame. Also for each frame. I think you go back to multiply this English, otherwise
Okay.
not easy to understand. These are four marker, not markers, four marker positions. About map from logo to these are four marker position about 逗点. These are four corner, four marker position 逗点. 只要 map 到谁，使用 perspective transform. The hint equation 是什么？这边的 hint 是什么？四个 hint 是什么？你这个回去再重来。是你的那个 logo 的四个点是自己要找，是你要自己要找，还是你要用 mouse 点
四个点的话，you use the corner of the image.
是啊，我说那个是要自动找，是你要知道。
You use the image size to get the four corner.
然后这个就是 work 嘛，那你像这属于关红发表。
Yes.
缺点没关系啊，要教他们不要让去猜，所以前面那个点这样写啊，因为你们都一样，那个11像11那边比如说11页那个啊，你可以说 using 什么方式去做什么事情。
Right. Okay.
开始可以适当给 using 什么什么的叙述。这边讲的不是很清楚，看一下，讲清楚一点。再改。
好。Okay. Next.
Okay, so in the fourth question, you have two sections, and you have to do in the first section you have to do the image reconstruction using PCA, and the second one is you have to calculate each error between the original and the reconstructed image. So in the first section, you will be given 30 company logos. And what you should do is using the PCA to lower down the original image dimension. And after you lower down their dimension, you use the dimension you reduce it and reconstruct them back to the image.
You want them to do the Python,
Yes, by using the Python.
suppose it's C or C.
Oh,
So
yeah, you can use the Python language because it's easier. So
easier not to.
I believe is the
If AI user even not using it's better not use
oh, okay.
it's slow. But anyway it's fine.
Yeah.
So other question will use other question will use which one? Which language?
I believe all
Question 1, 2, 3 will use.
yeah, all of the question will be used in Python. Okay.
AI using Python. AI using Python. When you use OpenCV, not AI better not use Python.
Okay.
That's the
Mhm.
that's the OpenCV for. OpenCV because they have some speed up. Using C they already speed it up. So that's why we use Python. We use OpenCV because if we use C or C++ for the OpenCV function, that'll be faster because they already optimize the code. So using AI, if you using AI, use the Python, it's fine. If you not use AI, it's better not use the Python. Especially when you go to company to work, company don't like use Python, except the AI. So next year don't use next year. It's not good. Especially you guys is not good. So when we work with the company, actually they all ask us, said they want us to use C or C++ because Python is slow. Except the GPU AI.
Okay. So you can use the C or C++ if you want. But so back to the point. So we reconstruct the image using the PCA, and you can use the function written in the hit below.
So first one is how many images?
First one I will give you all 30 image and
30.
yeah, total 30. And after you do the reconstruct image by clicking the button, the first section button, and you will be we need you to show us 30 image of 30 original image and 30 reconstructed image.
But they don't,
like
they don't know the icon do that.
Yeah, so you will be recommended to use the matplotlib pilot.
What's that?
This is a Python plot function you can use to plot out data and image.
I mean, they can learn nothing from here. It's code function and then output. It's the input and then kind of result.
Yeah.
Original images.
Yes.
Function and kind of result.
Yeah, they will be used to call the PCA function to reduce the dimension. And then
so how many dimensions they will reduce?
It depends, I believe.
In your case.
Well, in my case, I did not fix the dimension, how many dimension you'll be reduced, but in my case, you should reduce up to 80%. I've forgotten how many, maybe I will try to find it out later on.
The function, they will ask you to do that or not?
Yeah, the function will ask you to the function will ask you how many dimensions you want to we finally output that. Yeah.
To do that. Otherwise, you result everybody different.
Okay, so in this case, I believe you need to reduce up to 90.
It's fixed.
Yeah, fixed.
Everybody will be the same.
So in this case, let me think. You can reduce the
You can do that later.
yeah the dimension. Maybe you reduce like 20%. So you may remain like 30% of the dimension, and use the 80, not 30, sorry, 80. You use the 80% of the dimension to reconstruct the image. Yeah. So I explain it again. So you will be given
What's close to even?
yeah 30 logo.
No, it just got 30 logos.
Yeah, 30 company logos image.
Don't write close 30. This doesn't mean 30 times.
Okay.
Even 30 images of a company logo.
So you will be given 30 images of the company logo. And what you should do is using the PCA, calling the PCA function. Calling the PCA function and do the dimension reduction. Yeah, you reduce to 80%. Oh, maybe I mistake. I mean 80% is you will output the 80% of the dimension. So my meaning is reduce to
Imagine reduction
yeah.
to 80%.
Yeah. Okay. So you use the remaining 80% dimension, you reconstruct the image back. And when you click the section button, you need to output the reconstruct those 30 image origin image and the reconstructed image like down below using the matplotlib function. And to prevent some cheating, you should not save the reconstructed image. Instead, you should just plot the result image without saving it up. So what I mean is when you click this button, you load all of these 30 images to the PCA function and do the dimension reduction and the reconstruction, and you just immediately output the result. No saving is allowed. Okay. So in the second section, you have to calculate the error between the reconstructed image and the original image. So I give you the function, the reconstruct error function below. You should do it in each image by calculating. You should calculate all the reconstruct error by using the what should I call root square sum. Yeah. And after you calculate all of the error and you click the button, you will need to show us all of the 30 reconstructed error using this array.
对了，那个测学机，比较小数目。没有人取用
这还好，因为这是你直接扣那个。
我被骂过了。
哦。
去中正大学学长弄这个，我被机械系老师骂说你蛋，这个基本都不懂。OK， 没有那么多位的啦，笑死。
Okay, so you as discussed early on, so you don't need to do it in double. Instead, you need to show us in integer. 小数，因为可能他们还要做很多的那些方选的 calling 去把它去调，反而会让那些学生更麻烦的。是啊，虽然的确老师，我认为老师的讲法是对的，对，
大家都这样子。
对，大家的确是对，大家的确是要这么弄，但是如果要这么弄的话，就是会让他们更麻烦。对，
你整数可以，你没有人小数可以那么多位的。
是的。
去中正，人家说你成大学院的学生这么烂。
对，的确，谢谢。So you will require to use it to calculate the error and turn them in integer. I will correct it later on. And you print it out all of the error by clicking the button, the second section button. And I give you the hint is you can do it.
当每张都这样看。
No. You can just you should. How do I say? You will need just all will be print all this array out.
等一下让他好改。都看3。
Maybe function will work.
平均误差吧，对不对？学弟好改。先讨论一下，不要让学弟每张都看3次。我取最大值也可以啊，对不对？最大误差、最小误差嘛，平均误差嘛。稍微再改一下。OK， 是吧？但是我说让学弟好改。
Okay. So is there any question?
What's the hint to the other one?
This hint, you can by using this calculation, you can do it in you can do this calculation in the first section, and you may store the answer into the another memory, or don't know how you anyway you can store it in any way. But what you need to do is when you click the button, the second section button, I need to see the arrow. Yeah.
Get the maximal error.
Yeah. Maybe you should we will discuss it later, and you may maybe you need to output the maximal error, minimal error, and the median. We will discuss it later, and we will with the result we will give you later on, maybe today or tomorrow. Yeah. Yeah, before doing the reconstruct arrow, you must normalize all of the original image and the reconstructed image to the gray value from 0 to 255, and then you shall do the reconstruct arrow, because the original image will be given to RGB. So to prevent the RGB, because different RGB you have different value, right? So we suggest you to turn all of them to gray value. Yeah.
Should write step by step. Not right there. Not right there. So that the consumption, the input will be gray value, output will be gray value.
No. You
But I don't understand.
this will be RGB. The first one you need to show it as RGB image, and the second one you need to calculate all the error before you calculate the reconstruct error, you should turn off the image to the gray value.
So the important
Yeah.
The important one don't write hint. Important one just write. First of all, usually transfer all the color image to gray value. Wait, not like that right now. Let it go home.
Yeah.
Q2 usually write something.
Yeah.
Don't write on hint.
Yeah, that's my mistake.
Q2 first step is transfer all the image to the gray value.
Yeah. So in the second section, you should transform all the image to the gray value, and then you should do the reconstructed error. Yeah. And you may do it in the first section, but the first section, we want you to show us the RGB image. That's all. So is there any question? Yeah, I believe there's not. Okay.
Okay, so for question 5, we're going to train a cathode classifier using ResNet 50. And in this question, we'll have 6 parts here. And so next, I'm going to introduce a little bit about this question. So the first one is objective. And in this question, you will learn how to train a ResNet 50 model to classify images of cats and dogs, and learn how to deal with imbalanced data. So here the model we're using is ResNet 50, and so in ResNet 50 it has 2 characteristics. One is residual learning. It helps avoid degradation problems. And the other one is bottleneck. It allows us to build a deeper network without additional parameters. So we can take a look at this figure here. This is a residual block, and you can see here we have convolutional layers and a shortcut. Here, this arrow is the shortcut. So the input feature maps can be passed to here through this shortcut and combined with the feature maps that extracted from the convolutional layers. So, and this is the shortcut, and after combining that, we can help avoid the degradation problems. And next, we can see here, this residual block, the input is 256 channel feature maps. But here we use a 1x1 convolutional layer to reduce them to 64 channels. And after that, 3x3 convolutional layers use these 64 channel feature maps to extract more features. And then after this, we use another 1x1 control layer to enlarge the channel size to 256. And this is called the bottleneck, and it helps us to reduce the number of parameters. So this is the basic of ResNet 50. And after that, we can take a look at the diagram on the right. This is the structure of ResNet 50 model. And the input is a
224 by 224 by 3 channel RGB image, like this image of cat. And this RGB image will be input to the 7 by 7 convolutional layer with 64 filters and stride 2. So the stride 2 is used to downsample the feature maps. So we will get 112 by 112 by 64 channel feature maps here. And after this convolutional layer, we'll go to a 3 by 3 max pooling layer with stride 2 to downsample further. And then we're going to 4 sections of residual blocks. So this one is the first section. This is the second section. This is third section and fourth section. Okay, so in the first section, we have 3 residual blocks here, and all these 3 residual blocks have 1 by 1 convolutional layer with 64 filters, 3 by 3 convolutional layer with 60 filters, 1 by 1 convolutional layer with 256 filters, and a shortcut. And this is used to extract more features. And so after these 3 residual blocks, we'll go to the second section and here we have 4 residual blocks here. And the first residual blocks has a 1 by 1 convolutional layer with 128 filters and stride 2, and 3 by 3 convolutional layer with 128 filters, and 1 by 1 convolutional layer with 512 filters and a shortcut. This residual block is used to downsample the feature maps to 28 by 28 by 512 channels. So after downsampling the feature maps, we have 3 more residual blocks, and this has a similar settings like these residual blocks, but in these residual blocks, we don't need to use stride 2 because we don't downsample here. We just further extract higher level features. And so the remaining 2 sections, it has similar structures, just like the section here, but with different filters and different number of residual blocks. You can read it after this class. Okay, so after these 4 sections of residual blocks, finally we'll go to a global average pooling layer here to calculate the average values of these 2048 channel feature maps. And then we'll go to a fully connected layer with 1 output node to output a single confidence values, and the values ranges from 0 to 1. So what does this mean? If like the input, this is a cat image, and if our class label for cat is 1, and the output confidence value should be close to 1. And if like if our the class, if we input another image of dog and the class label for dog is 0, and the value should be close to 0. So we use these values to decide what the input is, and this shows how confident the model think the input image is a cat. Okay, so this is the model, the structure of Resident 50 model, and then we'll move on to the data set in this homework. We're using cat and dogs data set, and this is modified from Kaggle cat and dog data set. The data type is JPG images, and it has 2 classes here, cat and dog. So and if you download the dataset file, you will see these 3 folders. One is training dataset, which contains 16,200 JPG images. However, the dataset is imbalanced, so
there will be fewer cat images and more dog images. But later I will tell you how to try to deal with this class imbalance problem. And then the second folder is validation data set. It has 1,800 images here. And the last one is inference data set. It has 10 images here, and it is for testing your inference function in your GUI program. Okay, so I forgot to say that you will need to use this training data set to train your ResNet 50 model and validate your ResNet 50 model with this validation data set. And you will need to write a GUI program to give the inference function, and you will use inference data set you can use this data set to try it. Okay, so let's move on to the requirements here. You will need to train ResNet 50 models with TensorFlow or PyTorch using Python. And the second one is every chart. Okay, I will talk faster. Oh, next one.
Explain page 18, and then others we explain next time.
Okay, so
It's fine, but we explain others next time.
Okay, I'll finish this part here. And so every chart you draw, you should include a chart title and axis titles. Like you will have a bar chart, and you need to say what the title is, what is this used to, what you want to show us. Okay, so the last one is you should organize your files in this structure. And the first one is the project folder, and the file name should be HW205, and your student ID, your name, and the version of these files. And then in this folder, you should contain a folder called model to put your trained models here, and a folder called inference data set. And this is just the inference data set I give you, and you should put those images here in this folder. And then you should your GUI, you have to make a GUI program, and the code and the file for the program is called main.py. It is the code for your GUI program. And then train.py is the code for your model training. And that's the file we need. And you may put some other files or folders you need in this homework. So yeah, you have to put the files in this structure. Okay, so
we explain that one next week. Explain
after each question. Okay.
OK，没关系，下礼拜再讲。
好。
So we explain question 5 next week because the time is up. Okay, so that's it for today's lecture, and you can try to finish question 1 to 4 first. Okay, and next week we explain question 5. Okay, thank you. So up to here. Thank you. 谢谢。